and today we'll be building this little project here. So this is just a simple third-person camera system which has zoom functionality. We can move our character around, and the rotation of the camera through the mouse input is going to rotate our character. And also, as an extra side feature here for our camera system, I'm also going to be doing this little shoulder camera technique here, which you can use to make out-of-world scenes or just a simple shoulder camera for your action project later. So this project is not going to handle anything related to collisions whatsoever. This is just strictly the minimum barrier project for a third-person camera system. So let's get right into it. We are going to start here with a blank new project, and let's see how we're going to be building that. So at first, there are three things we need to build: a player, a character, and a third-person camera system. So alright, let's start our project by creating some sort of world here so we can see stuff. So I'm going to add a 3D node. I'm going to add a mesh instance here, so it can be a simple floor to our world here. I'm going to go inside its mesh and add a new plane. Through the plane measures, I'm going to give it a 6x6. I need some space here. And let's scroll down here to geometry, and let's find the part where it goes about the materials. Let's add a new material here. And I'm going to open the material, go through its albedo, and let's add the default icon as our albedo texture. So let's just drag and drop that inside our texture. And to make it look a little more like a floor, I'm going to just lower its albedo color a little down. So there we go, we have our plane texture. Next thing I want to add to our scene here is just to set up the environment and the sun. So just for testing purposes, if I add a camera here, and let's place it on top here, and I'm going to just rotate so you can see our little plane there, and let's press F5 to run the scene. You can also do that through project. Let's press F5 to run the project, and you can also do that by going here and simply click on that button. Now it's going to say that node scene has been defined as the main one, so let's cancel that and let's quickly save our scene as main in the default resource folder there of our project. Now, if we click that again, and I'm going to say select current. So it's going to run the default scene as that one. So what you're going to see here is a complete unlit scene without an environment in which we can see our floor texture. But as you can see, it is not light, nor does it have the environment we see on our editor. So what's going on? We actually are running the scene like this. So this will be without this sun preview and without our preview environment. So if you want to add this back to your scene, you simply open the dots here and go to add environment to your scene. It's going to create a world environment node through using the options you see here on the preview window. And let's also add the sun to our scene. Now you're going to notice that these icons have disappeared because now we have a sun and environment to our scene. And whenever we run our project once again, you're going to see it's going to be lit just like we see in the editor window. So that is just, we have some default things to work with. Now I'm going to remove that camera because we no longer need it. So now we have our testing scene ready to roll, and we're going to save it. So a script template is a simple script we'll be using as the base whenever we create a new script. It will be used to structure our code. So let's go right here and let's create a new folder. And let's call this script templates. And inside of it, let me add another folder that's going to be mean the type of node that I want for that. So this is going to be a simple node. And inside of here, we're going to place the new script. So let's create a new one. And let's place it inside our script templates node. And I'm going to be naming it something like our main custom script. So this is just something we know what it's about. Okay, let's create a new script. Now, a couple of things here we know we are going to do to change it. So I'm going to replace these comments. We're not going to need it. This one as well. By the way, to reduce the entire line is Ctrl X. Then let's just delete these. And let's place here the structure that I mentioned. So first, for this template, I'm going to be adding some custom methods here. This only applies to the template itself. So this is the name that's going to appear on your script list. This is the description is going to appear, and if it's used for default whenever you generate a new script, and the ident space lines. So this is just some setup information. Now regarding the template itself, so the script template itself is just these comments here. Now these comments represent a code structure that is very important for you inside of Godot whenever you are coding. More on that, I have a specific video that talks entirely about this. So if you want more information, you should watch it later. So for now, let's just copy these methods here inside our built-in override methods. And let's just place it there. Right, so now we should be able to save the script, and this will be used whenever we generate a new script. So now let's take care of our basic character that we'll be using to move around. So let's create here a new folder. This folder is going to be called the human char for a character, and this is going to hold our human character. Now that we have a folder for our human character, let's go right ahead and import our base human 3D model that is going to be used as a human reference for our character here. I just reloaded the project to import the human base character. I don't know if it's up with this version, but I need to re-import it I need to go to the project, reload current project to actually re-import the files. So that is done. I'm going to go back to full screen mode. And as you can see, now we have, this is the basic reference model that I'll be using to just show on the screen some kind of human reference for our character 3D person. So let's close that up. Let's create up a new scene here. Now this new scene, I want to be a character 3D, just so we are able to move it. And this should provide basis for other tutorials as well. So let's drag and drop our 3D human model here, which should be facing -Z. So this is the front facing it. And let's add here a script to our character body. And actually we can save this one. So let me just rename this to human char. And let's save this under our human char folder as main. So this is the main scene for that asset. Now we have the scene we should be using and our asset imported right there. Now let's go right ahead and attach a new script to this one, which will be handling the code for it. And we also like to use main. Now here on templates, you can see that we have a node custom template, which is the one we built right before it. So now whenever I create a new script and choose this up here, node base custom script, is going to generate that structure we defined on the node main custom script for the template, which is this one. So that is why I generate that template. So now we have a basic script we can start working on it. So for this human character code here, there's nothing that complex about it. We're going to start by adding two new public vars. So let's declare a new variable here, which is going to be our move speed, which is a simple float. And this is going to be 2.0. You can also fine tune this later whenever we finish the tutorial. Let's create a new variable, which is going to be our rotation y speed. And let's also assign this as a float as 10.0. So these are the only variables we need to make that sample project. Next, let's go to our public methods and let's add two new public methods. The first one is going to be the function to move objects. So let's declare a new function and we're going to call this move tool. And we are also going to be needing a goal as argument, a vector tree. We're also going to be need a speed to that, which we're going to be inputted as a float, which by default is going to be equal to our move speed. That function is not going to return anything, so we're going to type it as void. And yes, this is using static typing. Next, because this is a character body 3D, we are going to use the function move and collide. So this will make more sense later on other video parts, but basically this is up to us to implement the move functionality to our character. But on this case, it's going to be pretty simple. It's going to be our goal multiplied by our get physics delta time, and multiply finally by our speed. So this in turn should provide movement to our character. I don't know exactly where the issue is. Oh yeah. Now it's saying that move and collide do not belong on this base self because it's extending for node. Because our template by default extends for node. So we want to update this to be extending for character body 3D, which has this function move and collide. You see what just happened? I really didn't know what the bug was, but something in my mind just clicked. That type of click is called critical thinking and problem solving skills, which I'm going to happily present to you a solution that allows you to learn this type of thing. Programming is not all about math and code, but also creative thinking and problem solving, which is very hard to learn. However, if you have the right tools to learn it in the easier way, like Brilliant offers, part of its mission is to develop the most effective way to learn, with lessons filled with hands-on problem solving that lets you play with concepts in real time, which is way more effective than just watching theory videos. I usually try to learn vector math here on YouTube, but if I was using Brilliant, I am sure I would have learned way faster than I did. They allow you to develop a daily learning habits to build the problem solving skills you need in order to code in Godot or any other game engine. Really, it's about learning how to think critically, which you can with Brilliant very easily. Look at these interfaces and animations, they are very intuitive for you to learn new skills. So if you're looking to improve your skills, check out Brilliant. You can try everything Brilliant has to offer for free for full 30 days. Check out the main link on this video description, or you can also scan the QR code that you see on the screen. You will also get 20% off an annual premium subscription. Thanks for Brilliant for sponsoring this video. Alright, so this should take care for all the needs for this character to move around. Now, also another note, since this tutorial is not about collisions, I am not going to be doing anything regarding collisions. So you can see that it's asking for a collision shape and stuff, so we're not going to do anything about this. We'll be handling the collision things on the next video, so for now let's just take care of the camera system. So the next thing I'm going to be creating is the player input system for this object. So let's go right back to our scene and let's just add our main character here to our scene. Voila, now we have our scene with a human character. However, this character is controllable and nothing happens. So let's just leave it at that. And let's create now a new folder here. So let's create a new folder for our player object. And now let's add a new scene, which is going to be a node, which is simply the inputs from the player. We're going to be connecting to other characters and stuff. So let's rename this to player and let's attach a new script. So before of that, let me just save the scene as main inside our player here. So this is the main scene for our player object. Next, we want to attach a new script also inside of the player, this time extending for the same custom-based script. Alright, now let's go through the code for our player here. So let's extend for node, that is alright. Alright, so on export, let's create a new export var, which is going to be our player entity. So here we're going to simply point an object in our game that is going to be controlled by the player. So that is what this will be used for. And export simply allows you to add a new field here, which you can assign an object. And this will be quite useful whenever we drop the player inside our main scene. Next, we want to grab here a node on as a onReady variable for the camera. So we're going to be apply some commands to our camera here. We're going to need some information from it. So we're going to need to store that camera as a variable here. So we're going to create a new onReady variable. And onReady just means that whenever we start the object, we're going to assign this variable. So let's create a new variable called camera, and this is going to be a camera 3D. And we're going to grab the camera by not specifying any relation whatsoever. So we're going to grab for the current viewport the camera itself. So this is not a path, a node path like you point other objects. This is just going to grab the current camera 3D from our viewport. So from our current viewport, we're going to grab the camera 3D. So this here is going to return us the current active 3D camera. So whenever we generate the camera from on camera system, this script itself is going to allow us to grab the camera object itself. Now that is done, another thing we are going to do here is, and for that I'm going to be doing a little test here, but for now let's just minimize this, let's save this. Let's go back to our main scene here and let's add our main player scene here. So by itself we're not be able to see anything. Let's just see what that looks like. So we're going to be dropped at the feet of the player. Yeah, we're not going to see anything. So let me add a simple camera here just to set up here something. And we're going to set it as current. So whenever we run the scene, we should be able to see this. So what you're going to see is whenever we start running the project, you're going to see the mouse, and we do not want to see the mouse icon whatsoever. So one of the ways you can do this is on our player main script code here. Let me just maximize that. We're going to be adding here a simple command. So we're going to go through our input singleton and we're going to set the mouse mode as captured. So this you can do through input.mouse mode captured. So what this is going to do is whenever we run our scene, whenever the red function for this main object runs, it's going to set the input mode, and we're going to hide the mouse icon whatsoever, so you can no longer see it, and that's because of this line. Then you can see more details information right there. You can change the mouse capture mode, and there's a few modes here on the enumerations, and you can do this as well just by pressing Ctrl and hover inside a topic, and whenever you press it, if it has some information inside the engine, it's going to present itself as documentation, and you can see listed here under docs. So pretty cool stuff. Let's go back to our player here, functions, and let's change some stuff. So inside our main player function, we are going to be setting the inputs through the physics process. So I'm not going to be applying it under process, but just under physics process. It's going to run a little fewer times, and I would like to prefer that for my functions. So the first thing I want is to grab our inputs movement direction so we can apply it to our player entity. So let's create a new variable here as inputs direction, and it's going to be a vector2. So we want to grab a vector2 from our input singleton as get vector. So this is going to, what it's going to do, is going to grab a input direction as a vector2 from our current inputs. And here you can specify 4 different inputs to be specified as negative or positive X and Y. This is mainly used for you to do movement-oriented things. So before we go right ahead and start typing here, we need to set up the inputs for this project. So let's go right ahead on our project settings. Let's go ahead to input map. So here you're going to add all the project inputs you're going to use for this one. So let's start with, I'm going to speed up this process and you're going to see what that is all about. So we're going to be creating a new action, which is like this, move forwards. Then you're going to press the add button. Then we're going to add the new input, and we're going to press the keyboard a key if you do not want to select it through here. So I'm going to press W, and this is going to represent move forwards inside my project. So now let's go through all the other actions. I'm going to be speeding up this process so you can see it very fast. Now for the zoom function, we want to use the mouse wheel. So let's open the mouse options and select mouse wheel up. The same for the zoom out, so mouse wheel down. And there we go. We have a bunch of inputs now we can use, and we have the inputs itself from the devices we want to be called these actions inside our project. So whenever we hit close here, we can now say that we want some inputs to define the input direction variable here. So we want to define as vector2 some inputs here. So the first one, if you press Ctrl space for the autocompletion list, is the negative X left. So this should be the X negative value. Then next we want the right. Now for the negative Y coordinates, we want to move forwards. And for the other one, we want to move backwards. So for us to be able to see this better, I'm going to press enter here, so we can have a better visualization of the code. So now that we have the input direction from the player through the input devices we have set up in the actions, we're going to need an input rotated towards our 3D camera. So let's create a new variable. This is going to be an input direction 3D rotated to our camera. So rotated to cam. And this is going to be a vector3, which we're going to create now. And this is going to be using our input direction first as its X value. For Y, we don't need any Y inputs. And for Z, we're going to use the input coordinates on its Y position. So that is why we have set that up. So next, we want to rotate this input. So after we have defined this vector, we're going to rotate it towards vector3 up. And we want to rotate it, and here's going to ask, but you want to rotate it towards what angle? And we're going to say towards our camera, dot global rotation dot y. So you're going to see why all of this code, what this means, in just a second. Next, we want to move our player entity. Now, we have set our player entity here as an export variable, and we are going to be assign it, and actually you can assign just now. So if we go back to our main 3D scene here, and we select our player, we can assign a player entity node here. And as you can see, you can assign our player human character. So we want to control this character through using the actions and script from this object. So if we open the script for this one very quickly, we have two functions, which is the move tool. And of course, I forgot to create the rotation function. So let's create also the rotation function. So this is going to rotate our character, and of course I forgot it. And so this function is going to, it rotates the Y into D. And this is the comment that belongs inside the function. So let me just create the current position into D on its Z axis, which is going to be a vector 2. And we're going to be creating this one by using the global transformation. So we're going to use the negative global transform on its basis, on its Z through its X. So if you don't know how to handle bases and transformations inside of Godot, basically we are grabbing the global transformation position of the player entity. We are assigning it through its basis. We want to grab the Z axis on its X value. So we want to convert the 3D global transform basis from top down to a 2D vector, so we can apply rotations to our character. You do not need to know exactly how this works if you are not an expert or advanced user, but just know that this works. So we also need to be using the basis. However, this one is the Z vector we want, and this should close up our current 3D position. Next, we want to create a new variable, which is the Y angle that we're going to be grabbing. And this Y angle is going to be used to rotate our object. So let's create a new one based on our current position to the Z axis and go towards our goal. And this is a lot of manufacturing functions to just rotate an object. And this has to do with some issues with signing vectors with rotations. You don't need all that stuff. Next, finally, we're going to rotate our object. So because this is a character in body 3D, we can simply grab its rotation y-axis, and we can deduct this value here, which is going to be our y angle, multiplied by get physics process delta. And yes, I'm using a lot of physics processing delta time to actually rotate this without regarding the frames per second. So that is why you use process delta time. So this function should take care of rotations towards a goal from a human character. And of course I forgot to do that because on the player code here, we're going to be using it right now. So after we have done that, the first thing we're going to do is move our player entity, and we're going to think that our objects assigned as player entity has one. We're going to expect that they have this function, because if they not, a function is going to throw up an error. So if you see any errors regarding this function that does not belong on the object, make sure your object has those functions listed here. So we're going to be moving these objects towards our input direction 3D towards the camera. And finally, we're going to be rotating our player entity. So rotate to, this is also a function we have built inside of our character object we are expecting to have. And we're going to be rotating towards our input rotated to the camera on its X and Z axis. So input and Z. So now if we run the scene, let me see what we have. It's going to say that expected one argument. So let's see what we mess it up. And of course, I define it as 2 arguments when we actually need one vector 2. So this is just a simple detail here. Now we have assigned a vector 2 instead of 2 arguments. And now we can run the scene. It's going to run and we should be able to move our character. So what actually is happening here if we do not have built a camera system? Because we have grabbed our camera from the viewport 3D camera, is grabbing the camera information from the camera 3D we did here to preview the scene. The code itself is going to move the object regarding the camera by using the inputs rotated towards the Y rotation of the camera. This means if we run our 3D scene where the camera rotates towards another place, so let's rotate towards there, you should see the inputs aligned with the camera itself. So you're going to see that inputs are rotated towards the camera rotation. So that is why I applied that line of code right there. That is why this thing here we built, so we can rotate the inputs we grab from the player towards the global rotation of the camera. So we could actually do this in real time by going to our project settings, and let's show advanced settings because I don't remember where it is. And let's type here always on top. I think that's the case. So now that we have set always on top, whenever we run our project, we can mess it up. And of course, I forgot to hide this as well. So on the player main custom, I just hiding the comment line so we can see the mouse icon. So I can mess it up. And while we are still seeing the project, so I'm going to see if I move my character is moving along the Y coordinates. And if I move my camera here, you're going to see that the inputs is going to align with that. So that is why we rotate the inputs towards our global rotation of the camera. And we should be able to see it moving towards the camera. So there we go. That is why we do it. Let me just rotate it back where it was. All right, so now we have the player inputs and a human controllable character. Now the last thing we need is to create our camera system itself for the third person. So let's go right ahead. So for our camera system, let's build another folder here. This is going to be the third person camera. Let's create a new scene here. And I actually going to use a 3D scene for this one. I'm going to call this the third person camera. And I'm going to save it inside of the third person folder as main. And yes, this tutorial is following the principle I discussed on another video about folder structure. If you want to see what that is all about regarding this type of structure here, you can see on that video. Alright, now we have main. Let's attach a new script here, also as a main inside our third person character. Alright, now let's build a new script inside of our third person camera, not character. Now we should have these ones here. So let's build the node structure for our camera system. So we want to build a lot of node 3D. So let me just build one and press Ctrl D to duplicate this 2 times. Let's put one inside another. And let's add a spring arm 3D. This is the structure node we'll be using inside of Godot. So if you're following this tutorial with other engine, make sure you grab the objects that have similar functions. So let's discuss this structure right here. So the first one is going to take care of rotations inside the Y plane, the second one in the Z plane, in the X plane, and the final one in the Z plane. The spring arm is going to take care of collisions with the camera against 3D objects. So this structure is just so you have automatically a system that can work with 3D objects, despite this tutorial not being related to collisions whatsoever. So if you can apply this to other things as well. So first we rotate the camera in the Y, so on the green axis right there. After we have rotated the camera to where we want it, we want to start rotating on the X value, which is going to be this one. And finally, we're going to rotate the camera towards Z, so that will be the shoulder camera movement. And why we want to split this up? To simplify the process. And after we have done all those operations at the same time together, we're going to actually be able to see our 3D person movement camera as we want it. And finally, in the spring arm 3D, you make sure you do not get inside any collision objects, such as the world environment or other objects that have collision information. So that is basically everything you need for the camera system to be working as it should for a third-person character. So now let's take care of our code. So this is going to be the main hurdle of this tutorial. So at first, for exports, we're going to need a variable, and this variable is going to be our target node. So our camera system needs to know which object is going to be falling around, and this is simply to teleport its position, nothing else. So let's actually create a variable to do that. So let's create a new one, which we're going to be calling it anchor offset. And what this is going to do is basically create an anchor offset for teleporting our camera back to a target object.